Welcome to virtual algebra class. We are going through our series on graphing here today, and we're going to be talking about finding slope when given points. So hopefully some of you guys saw the last video that we did on introduction to slope, so you have some idea what slope is. Any of the ladies in here know what slope is? They're like, no. Tell us. Okay, so slope is a measure of the steepness of a line. And basically, we're looking at how fast a line rises. So, or false, how fast a line rises or falls. Okay, so I went into this in some depth in the last video, but to let you know, the important thing here is if I want to find out how fast a line is rising, what I've got to do is I've got to measure how quickly it goes up. Okay, so I mean, if I hold up a line right here and I have it down like this, you can obviously tell it's not very sloped, it's not very steep, because it's not going up very much, it's mostly going over. Does that make sense? Mm-hmm. Now, if I hold up a steeper line, we can see that one's going up a lot, and it's not going over as much, it's mostly going up. And that's the idea here. And so the way we do this mathematically is we make a ratio of what we call the rise. That's the change in y value, how quickly you're going up, over the run. And the run is the change in x value, or how quickly you are going over. So how quickly you're going up divided by how quickly you're going over. Rise over run. Is everybody cool with that? Okay. So, sure. So I'll be watching that other video. Okay. So today, the last video we looked at how can we find that on a graph. So I'll just remind everybody that when you're given a graph, it's easy to count the change in y and the change in x. You literally just count the rise and you count the run, and you turn them into a fraction. Rise over run. So for example, if I was starting at a point on my line and I was going to another point on my line, I could just count how far I would go up. Maybe it would be 3, 1, 2, 3, and how far I'd go over. Maybe it'd be 5. So then my slope would then be 3 over 5 because I went up 3 and over 5. That's an example of what it might look like on a graph, okay? But you're not always given a graph, okay? So you might be given points and be asked to find the slope. So hopefully you guys have seen the intro to graphing video where we looked at points. So how can I recognize a point? Basically, you can recognize a point because it has an independent variable and a dependent variable. That's that interplay. Those are the two related numbers. That's all I mean. The x and the y, we often call them. Okay, and we did look and see that coordinate points were usually in parentheses. They have an x coordinate or an x value, and then a y coordinate or a y value with commas between them in parentheses. That's an example of what a point might look like. Now, of course, those values would be numbers, right? So it might be like the 0.34. Okay, so now if you don't have drawn a picture of a graph, so let's take a look at an example of what I meant. So you could just be asked something like, what is the slope of the line containing the points 1, 1, and let's do something nice and simple. 5, 2. Okay, so could you just put these on a graph, draw up a graph, put them on a graph, and then do the slope the way we've done before? You could, but there's a quicker way. As it turns out, and this is the key that you need to know, when given points, there is a formula you can use to find slope. Now, the good news is, even though I'm going to show you this formula, but this formula, like panic students, they think it's so gross. It looks disgusting to them. So I'm going to ask you guys to just let me explain it before you panic. Really seriously, because it's actually an easy formula. So I will remind you that we said that slope was equal to the rise, and I'm actually going to draw this out, over the run. And you might be saying, Kate, why are you saying the same thing? I just want to show you here that my formula is exactly what I've already been saying. It might look slightly different to you because of the mathematical symbols, but it's the rise over the run. And we said another way that we could think of rise is as the change of y, how fast your line is going up. Change of y over the change in x. So, okay, so let's talk about change, because students always look at me like the formula is some kind of new mystery that they don't understand. But what I've found is that students really do understand change. So I have a question for you about change, okay, ladies? It's this. If I weighed, let's say I weighed 220 pounds. I'm going to blatantly lie on the internet here. I weighed 220 pounds, then I went on a diet, okay? And now I weigh 180 pounds. By how much did my weight change? All the ladies know about this. I weighed 220, now I weigh 180. How much did my weight change?
40 pounds.
40 pounds. Did you need a formula to find change?
No.
No, you didn't. You know how to find change. What did you do with the two numbers? You subtracted. Now I got a question for you. Did my weight go up by 40 pounds or did it go down by 40 pounds?
It went down.
It went down. So would you say that an accurate representation of the change in my weight is negative 40?
Yeah.
Does that make sense? Negative 40. My weight went down by 40 pounds. We're really dreaming now, ladies. I've never been under 200 pounds in my adult life, but that's okay. A girl can dream. Okay, so and again, you guys never have problems with this. You know how to find change. So how did you just tell me you'd find change? We subtracted, right?
Mm-hmm.
Okay, so would you agree with me that if I wanted to find out how much the y changed, I would have to take the two y values and subtract them? Does that make sense to you? And if I wanted to find out how much x changed, I would have to take two x values and subtract them. Does that make sense?
Yes.
Let's go look at the formula now, and no panicking. Here we go. I'm not talking specifically to you, Heather, but that was a knowing giggle. Okay, here we go. So here's the GED formula sheet. Do you ladies have a copy of this?
I do not, but I will.
You should. I just got it by Googling GED formula sheet. And then if you print this out, you can do that. I can email you guys a copy if you'd like me to. You want me to email you a copy, Serenity?
Sure.
Great.
Anybody else need one?
Me too.
Okay.
Please.
Okay, so what I want you to notice is at the bottom of the page, I'll email it to Marilee and Serenity, but at the bottom of the page, you see the algebra section. Do you see that? Very first formula in the algebra section, look what it says. Slope of a line formula. You guys see it?
Yes.
And there it is. And maybe it looks pretty ugly to you. All that jazz right there, M equals. But this is actually a really easier formula than it looks. And so if you have this formula sheet out, you should definitely annotate this here. A couple of things you need to know. The first thing is that this top y2 minus y1, all I'm doing is taking the new y, y2, and subtracting the old y. That's the change of y. And then the bottom here, you can see me subtracting two x's, x2 minus x1, over the change in x. So this is not a new formula. This is just me talking about it in mathematical terms, okay? Now, the other thing that freaks students out are these little numbers down at the bottom. See how it says y with a subscript of 2? You guys see those numbers down at the bottom, the subscripts?
Yeah.
Subscripts freak students out because they think it's some kind of math they have to do. They're like, oh my gosh, it's some new math I never even saw. Kate never taught me this. That is not math, okay? Mathematicians use subscripts to talk about the ordinal numbers, So subscript represents the ordinal numbers. Now, the ordinal numbers are like your place in line. So if I said, what place are you standing in line? You wouldn't say, I'm in one place. You would say, I'm in first place, right? You're first, second, third, so on and so forth. Ordinal numbers. Does that make sense? So if I say y2 minus y1, what am I saying? I'm saying take the second y and subtract the first y, literally. Okay, there's two y's, so I needed to have a way to differentiate between them. And that's all I'm doing with those ordinal numbers. Is everybody cool with that?
Mm-hmm.
Okay, now let's go use it. Did you get what I wrote down here? Can I move to the next screen?
Yes.
Sweet. Now, the great news is, of course, as you guys know, you do not need to memorize these formulas. You will have that formula sheet available to you as you take your test. So even if you think it's dumb to remember what that means and you would rather just plug into a formula, that will be available to you. I'm going to draw this out even though my handwriting is a little messy, but I don't have subscript. So the formula is y2 minus y1, and we said that was the change of y over x2 minus x1. We are going to use this formula every time we find slope. Okay, so let's do this example that we were looking at. What is the slope of the line containing the points 1, 1 and 5, 2? So my very first step as a wise mathematician is always to write out my formula without plugging values into it. I've lectured you ladies on this before, but when you start substituting in the values without writing down the formula, you guys make more mistakes than you should. Okay? Is everybody okay with me writing out the formula?
Yeah.
Okay, so, and notice I said m equals. Why? Because I'm speaking in complete math sentences. This says to find my slope, do all this jazz. Okay, now let's plug into this formula. So I had 2 points over here. I had this point 1, 1. I had this point 5, 2. You have to decide which one is the first point and which one is the second point. Here's the good news. It doesn't matter which one's which. As long as you stay consistent, you'll get the same answer, okay? So I'll call this one the first point. And I'll call this one the second point. So if I have my first point and my second point, remember that a point has an x value and a y value. So if this is my first point, that makes this x1 and y1. And if this is my second point, that makes this x2 and y2. And now I know all my numbers to be able to plug into this formula. So let's do it. First, they would like me to take the second y. The second y, y2. So I'll go to the y in the second point. That's a 2. And I'll plug that in. Now from that, the formula is asking me to subtract. So I will subtract the first y, the y from the first point. And of course, that's a 1. So 2 minus 1. And that's going to go all over, all over. I'll take my second x. What's my second x, ladies?
5.
5. And from that, the formula tells me to subtract, so I'll subtract my first x. What was my first x?
1.
1. And now, this might look gross, but it's just a straight up order of operations problems. There's a couple of groupings. Remember that the top and bottom of a fraction bar makes the groupings, and we always do our groupings first. So I'll do that. I'll do my 2 minus 1, that's up top. 2 minus 1 is, of course, 1. And I'll leave my fraction bar because I haven't dealt with it yet, and I'll do my bottom grouping. The grouping in my denominator is 5 minus 1. That makes 4. So I dealt with my groupings. As you can see, there's only one operation left. There's the fraction bar, which we know means divide. But sometimes things don't divide. Ladies, does 1 divide by 4?
Nope.
No, it doesn't divide. So I'm done. That's why fractions were invented, so I didn't have to do ugly division. Literally, that's why fractions exist. So I can stop right here and be lazy. Okay, so what is my slope? My slope is a 1 over 4 slope, which means my line is going up 1 for every 4 it goes over. I have a fairly gently sloping line. Does that make sense?
Mm-hmm.
Okay. Great. So That's it. This is the whole skill. This is all we're going to practice today. All I want to show you is some weird things that could come up on the GED. So did you guys get everything on this page? Can I flip to my next page?
Yeah.
Okay. Let's go look at some weird GED style examples. Okay, so example 1 I'm looking at first. It says, find the slope of the line containing the points -4, 1 and -1, 8. Again, I'll call one of them point 1 and one of them point 2. And as usual, I will write down my formula before I plug anything in. So I'm just taking this off the formula sheet, okay? I'm actually a liar. I'm not taking it off the formula sheet because I have the formulas memorized, but y'all don't. So it's the change in y's, y2 minus y1, over the change in x's, x2 minus x1. And thank you for being patient with my crappy handwriting with my mouse, ladies. Okay, so here's my formula. Now what I'm going to do is plug into it. And since I don't have room on the bottom, I will go right. Okay, so my second y, it's my y from my second point, and from that I'm going to subtract the y from my first point. Some people like to draw the arrows so they can see it. So I'm going to start with -8, and from that I'm going to subtract, and this is a positive 1, so I'm going to subtract 1. Is everybody cool with that?
Yes.
Now don't do the math yet. Some students get so excited, start doing the math, then they lose the whole bottom of their slope. Plug in all the values before you start crunching numbers. So now x2 minus x1. Again, I'm going to start in the same point and subtract out the same x I did last time so that I'm consistent. So I'm going to start with -1. And then I'm going to subtract because the formula says subtract. There's a minus sign right here. I have to subtract. Now here's the first place that screws up students. What is my first x?
4 minus 4.
It's -4, isn't it? -4. That means I need to minus -4. And so what the mistake students will make is they'll only put one minus sign, and yet there's two. There's the one from my formula, the minus sign here, and then there's the negative from my 4. That's two separate negatives. And we can deal with that, but we need to write it down first before we deal with it. Okay, so I have -1 minus -4. Some teachers will put parentheses here so you can see that that's what that means, -1 minus -4. Is everybody cool with that? Is that okay?
Yes.
Okay, now because you guys, we have not done adding and subtracting integers unless you're at that place in Odysseyware. How many of you guys have done adding and subtracting integers in Odysseyware?
I have not.
Yeah, so it's kind of a pain. So the good news is if you did this problem on the GED, you would have your TI-30XS calculator in here, and it can handle this math for you. In fact, you could actually put this entire thing into your TI and it would work it. But I'm just going to do it one step at a time, just like I would by hand. And so if I were to type this into my calculator, and be really careful because the negative sign is different from the minus sign. The negative sign has parentheses and it's on the bottom right-hand side of your calculator. So you'd have to type negative and then the 8 and then the minus button and then the 1. So when the negative sign's in front, you have to use the negative, but when it's between two numbers, you have to use the minus. Does that make sense?
Yeah.
Okay, so -8 minus 1, and if I were to type that, I would get -9. Okay, now on the bottom here, you can also type this into your calculator again, but you're gonna have to type -1 minus, and you don't need the parentheses, but you do need to type -4. So you have to know that when the minus sign is right in front of that number, then it's a negative, and when it's between two numbers, then it's a minus. So again, -1 minus -4. And if you were to type that into your calculator, you would find out very surprisingly that it's 3. Okay. Does anybody know why it's 3?
Because the signs change, correct?
Yeah, when you have two negatives in a row, it actually turns into plus. So this is -1 plus 4, like you were $1 in debt, but then you got $4, so you'd come up to 3. Okay, so now great. Now the final step that you should do is you should deal with this fraction bar. Now remember, fraction bar literally means division. So if you can divide it through, just go ahead and divide it through. Does -9 divide by 3? Oh, well, it Certainly does. -9 divides nicely by 3. -9 divided by 3 is -3. And again, your GED calculator can handle that. And so the slope of this line is -3. I don't know why I started with that one. I don't think I meant to. All these negative signs. How'd you guys do? It's
Pretty
okay?
good. Mm-hmm.
Okay, so this is the one I think I actually meant to start with. It's a little easier. Let's take a look at example 2. So again, I'm plugging into the formula M equals change in Y, so the new Y minus the old Y over change in X. And you guys are probably like, why does she keep repeating herself? It's because when you guys get to word problems, you're like, what? New, old? Yeah, Y1 and Y2 show up in word problems too. We'll see that next week. Okay, so Y2, that's the Y value in my second point, and from that I'm going to subtract the Y value in my first point. So in this case, I have 6 minus 4. And then my x2 minus x1, I'm going to take the x value in my first point and from it subtract the x value in my, other way around, sorry. X value in my second point minus x value in my first point. The biggest mistake students make here is just with their secretarial skills, they lose track of their x and y's. So neatness is your best friend. Okay, so 6 minus 4 is 2, and 11 minus 3 is 8. So let's talk about this number here. Does 2 divide perfectly by 8?
Yes. No.
So remember that order matters in division. If it was the other way around, if it was 8 divided by 2, I agree with you. I could take 8 groups, divide it into 2 perfect groups. I'd have nice, neat, I wouldn't have to cut anything up. But if I only have 2 things and I want to break it into 8 groups, I'm going to end up with pieces and parts. Does that make sense?
Yeah.
And there's 2 ways to express pieces and parts, decimals and fractions, but we leave them as fractions in the world of slope. We don't usually use decimals for slope. So I'm going to leave this as a fraction, but here's the expert tip. Write this down, ladies. All final fraction answers must be reduced. I don't care if I'm in the world of slope, if I'm adding fractions, if I'm converting a percent into a fraction, all final fraction answers must be reduced. Now, if you've got the background knowledge of how to reduce fractions, then lucky you, you can do this in your head. But for the rest of us, if you don't have the background knowledge to reduce fractions, it's not what I'm teaching today. And your TI-30XS calculator can do this. So in a TI-30XS, to reduce fractions, you'll type in the first number, which is 2, then you'll type the fraction button. The fraction button is the N over D button. N over D, numerator over denominator. And then you type the 8, and then you press enter. If you type that into your TI-30XS, it will reduce the fraction for you, or it will tell you that the fraction's already reduced. So 2 over 8, if I type that into my TI-30XS calculator, would come to 1/4. It would reduce to 1/4. 2 out of 8 is the same as 1 out of 4. Is everybody okay with that?
Yeah.
Okay, wonderful. Let's go a little faster. Okay, so it's not easy to go faster when you're trying to write with a mouse. So I have 2 tools that I can use to do this class, right? I have my little mouse, but I also have my tablet with the stylus. I love my tablet with the stylus, but then I have to write out every example. I can't have them pre-typed out because it can't write on the worksheets. So if I want to write on the worksheets, I have to do it with the mouse. It's like 12 of one, a dozen of another. I don't know which one's the better problem to have. Okay, so I have my formula. So help me out, ladies. I want to plug into it. What is the second Y?
5.
5. Absolutely. And from that, I want to subtract the first Y, which is?
-3.
I disagree. That's an X. Remember, in a point, this is an X, and this is a Y. So what would the first Y be?
5.
Also 5. Okay, now, on the bottom, I want to take my second X. So what's my second X?
6,
And from it, subtract my first x, which was
-3.
-3. 6 minus -3. Wonderful. So now let's do the math. 5 minus 5 is
0.
0. And again, you may do 6 minus -3 in your calculator, but I'm going to do it by hand. Negative, negative turns into a positive because the opposite of subtraction is addition. And 6 plus 3 is 9.
9.
Now, I have 0 things and I want to divide it into 9 equal groups. This is like I come up to you ladies and I'm like, I have no money. Let's share it between 9 of us. You tell me, if we took nothing and shared it between 9 of us, how much would each of us have?
0.
0. We'd have nothing. 0 divided by anything is still 0. And if you were to type this into your TI-30XS, you would get that confirmation. Is that cool? And you might be thinking, why is she stressing this? I promise I'm stressing this for a reason. And so we learned in our last video that a line with a slope of 0 is a nice flat line. So this is a nice flat line here. And that makes sense because if I was graphing and I went 6 over and 5 up, or I went -3 over and 5 up, whoa. That was a really ugly point. I would end up at the same height because on both cases I went 5 up, and so I would have this nice flat line. So I have a 0 slope line, a horizontal line. Is everybody cool with that? Okay, so what's the slope of this line? The slope of this line is 0. Okay, so that's one unusual problem that students will encounter. They won't know what to do when they see a 0. Next one, and this one's even weirder. Okay, let's take a look at example 4. So once again, I've been asked to find the slope. Find the slope. And once again, they've given me points. And so the easiest way to find the slope when given points, again, not the only way, just the quickest way, is to use the formula. Change in y over change in x. I just taught this to my in-person class yesterday, and I had all these students who were like, I hate the formula. And I was like, that's fine. If you hate the formula, just memorize the steps. Change in y, how much did the y change? I got to subtract them. Change in x, how much did the x change? I got to subtract them. And then I got to put them into a fraction. I mean, you know, it's up to you. But I like formulas. So there's that. So I'm going to take the second x and minus the first. I mean the second y, sorry, and minus the first y. So I'll do -1 minus 4. And then I'm going to do the same thing with my x's, my second x minus my first x. So I get 2 minus 2. Okay, so on top, if I'm already in debt $1, -1, and then I go down another $4, I subtract 4, I am really in trouble. I'm in all kinds of debt. I'm at -5. And again, your calculator can handle that if you can't. Now on the bottom, 2 minus 2, we don't need to know anything about adding and subtracting negatives to know that 2 minus 2 is 0. Now I really, really wanted to work this problem with you because this is the problem that students are most likely to forget. The GED knows exactly what you guys forget, and so I wouldn't be the least bit surprised if you had this one on the GED, okay? So I want to look at this. We have -5 now over 0. This is a very different situation. I'm not taking $0 now and sharing it between 5 students. Now, I'm just going to ignore the negative sign for now and just talk about the 5. But this is like I have $5, okay? So everybody imagine I have $5. And now I'm going to take it and start making groups of 0. I mean, imagine me making a group of 0. So I make a group of 0, another group of 0, another group of 0, another group of 0. How many groups of 0 am I going to make to use up the 5?
5.
Oh yeah? So if I make 5 groups of 0, the 5 will be all gone?
No.
No. I could have $5 sitting on the table, right? I could make groups of 0 until the end of time. I could literally spend the rest of my life making groups of 0. I could die still making groups of 0, and I would never have used up my $5. Does that make sense to you?
Mhm.
There's no way to use up $5 by making groups of 0. And so when the 0's on the bottom of the fraction, you cannot divide by 0. And so it is super, 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 super important that you realize that when the 0's on the bottom, this fraction is undefined. And this is useful both in slope And there's later problems on the GED that we'll see at a later date where they'll ask you, what values would make this fraction undefined? Whatever makes the bottom 0. We can't have the bottom of a fraction be 0, okay, because we can't divide by 0. Does that make sense to everybody? So this is super duper important. My slope is undefined. Okay, now hopefully if you saw the intro to slope video, you know then that this line must look like this, because it was my straight up and down vertical lines, the ones that weren't even functions, that had those undefined slopes. Undefined slopes. Okay, so these are some simple examples of finding slopes from 2 points. Yes, there's some tricks with the 0 thing. So when the 0 is on top, the answer is 0. But when the 0 is on bottom, the slope is undefined. But besides that, they're pretty simple. Does anybody struggle with these? No. So here's the deal. The GED is rude. I don't know why they don't just give you straightforward problems, but I see very few straightforward problems. They like to hide crap from you. Okay, so let me, yeah, Serenity, no, it's like, amen, sister, I saw that. So let me show you how they can hide points from you. That's the exact same kind of problem, but you don't realize it. Okay, so, and want to show you a couple of examples where students don't know what to do a lot. Okay, so here's my first GED example problem, example 5. It says, what is the slope? So again, they've asked me to find slope of the linear function displayed in the table. So here's an interesting thing they told me. They told me it's a linear function. Anybody know what they mean when they say it's a linear function?
Straight across?
Yeah, it just means it's a line. Linear, and you can see the word line in it, means that these things line up. They go in a nice straight line. Yeah, that's it. So find the slope of the linear function displayed in the table. Now students will take one look at this and they'll say, Kate, you taught me to find slope from points. You taught me to find slope from a graph. You taught me to find slope from, you know, a word problem or an equation, but you never told me how to find slope from a table. And I'm like, guys, what is a table? A table is just a series of X and Y values. So like this says when the bikes, the X is 5, the gross, probably this is some bike company's gross profit, is $13.75. That's a point. That's an XY value. So they hid it from you in a table, but it's still a point. Does that make sense? Okay, so I've got 4 points here. Here's a point. There's another point. There's another point. And there's another point. But I'm still finding slope when given points. So the quickest way to go is still to bust out the slope formula. So m equals y2 over y1, the change in y's, over x2, yeah, really bad, sorry. So over x2 minus x1. Okay, now this is the thing that our students freak out. They're like, well, what am I going to do? Which one's the first point and which one's the second point? And that's the deal. I mean, that's really what we have to understand about slope. What makes something a line is that it keeps going up at a constant rate. If it didn't keep going up at a constant rate, it wouldn't be a line. It'd be something else. You know, like, oh, now it's increasing, decreasing, it's going slow, fast. It'd be a roller coaster. But I'm looking at a line. A line is constantly increasing at the same speed. And so it doesn't matter what 2 points you pick. I say that again, it does not matter. I could pick 2 ones, Serenity could do 2 different ones, Heather could do 2 other ones, and Marily could do 2 other ones. And if we did our math right, we would all get the same slope because this is a linear function. It's a line. Does that make sense?
Uh-huh.
So pick whatever points you like. I'll do this one and call it point 2, and I'll do this one and call it point 1. Okay, so that means our second y would be this, 2750. And from that, I'm going to subtract my first y, which would have been this, the 1375. And I'm going to put that all over the second x, 10, minus the first x, 5. Is everybody cool with that?
Yes.
Okay. Oh, And now I have to do my math by hand because I lost my TI 30XS. Anybody got it on them? Because I keep, oh, here's mine. Yay. So I'm going to take 2750. I'm going to subtract 1375. And I get 1375. I'm all scarred by doing math by hand because I keep making dumb errors on the internet and getting corrected by random people I don't know. And then I'm going to do 10 minus 5 on the bottom and have 5. Everybody cool with that?
Yeah.
Now we said, if it can divide perfectly, you should divide. Anybody have any idea? Do you think 1375 divides it by 5?
Yeah.
Yeah, it sure does. It ends in 5. Of course it does. That's how our times tables, our 5 times tables behave. So I'm just going to divide it through, and I get 275. And so the slope of this line is giant. It's a 275 slope. This line is going up so fast. It's ridiculous. It looks almost straight up and down. Okay, is everybody cool with that?
Uh-huh.
Okay. I also wanted to show you that not only could they hide the points from you in the table, they could not even mention the word slope. That happens sometimes. So take a look at example 6. In fact, I would say that this is the most common GED example right here. Now, the good news is there's actually an easier way to solve this than we're going to do today. I'm going to show you that next class. So, you know, it's like a teaser. Please come next class. Okay. But for today, we're going to keep going with our formula. Okay. So the following table shows the number of miles Y that Tanya can bike in a certain number of hours X. And then look what it says. What is Tanya's speed in miles per hour? So whether you realize it or not, speed is a type of slope. If you're going at a constant speed, then what's happening is that your miles are changing at the same rate every hour you go. It's a slope because it's a rate of change. My big clue that it was a rate of change was the way they phrased it with speed. Notice they said it's the speed in miles per hour. Anytime you're talking about a rate of change, it's something per something. It could be miles per hour, miles per gallon, dollars per hour. Our pay rates are a slope. It's how quickly your bank account goes up the more you work. Okay, when you have a high pay rate, woo, it goes up quickly. When you have a low pay rate, you got to work and work and work and work and work to make some money. Does that make sense? Okay, so anytime it's a something per something, it is a rate of change, also known as a slope. And so they might not have ever said the word slope in this problem, and yet what you're looking for here is the slope. And so the slope formula will work for me because this is just a collection of points here. So I can bust out my m equals y2 over y1 over x2 minus x1. And again, you have 4 points here, 1, 2, 3, 4, but it does not matter which one you use. I'll call this one point 1. And this one, 0.2. Okay, so I'll take my second y and subtract my first y. So I'll get 100 minus 50. And I'm going to put that all over, and I need an equal sign in between because I'm a good little mathematician. 10 over 5. And again, as long as you're consistent, you're going in the same order, you're pulling from the same point, your answer will always be correct. So 100 minus 50 is, of course, 50. 10 minus 5 is, of course, 5. And this is division I can do. 50 divides by 5 perfectly 10 times. So I have a slope of 10, meaning that Tanya runs at a speed, I hope she's not running, oh, she's biking, of 10 miles per hour. And notice we use a slash for the word per. Why? I'm talking about that rise over run, the miles over the hours. Okay. How'd that work? Is that okay?
Yep.
Yeah. They love this, by the way. And students don't even know it's a slope problem. Example 7. It says the function below is linear. Remind me what it means if they say it's linear?
It's a line.
It's a line. if the data was plotted on a graph, what would be the slope of the resultant graph? And could we plot this data on a graph and look at the slope? We sure could, but we don't have to, because look what they've given us. Remember the curly Q brackets, we learned this in the function video, just mean the set of points. So this is the set here. And if you see what's inside this set, we see that they're points. There's a point, another point, another point, and another point. This is a set or a bag, like think of it as a bag full of things, a set of points. So since they've been asking me to find slope and they've given me points, once again, even though it doesn't look like the last problem, I can use my formula. And you guys are probably sick of me writing my formula down without plugging in, but I haven't met a single student yet who didn't follow this first step and make less errors in their substitution. Plus they memorize the formula faster. So you guys don't need the formula memorized for the GED, but I promise you, you need to know this one for your Math 092 and Math 120 course. So when you hit college, it's gonna come up again, okay? So which one would you guys like me to call point one? Anybody?
You could do a 410.
Sure. It doesn't matter. We'll call that point one. How about point two?
3.
This one?
Yeah.
Okay, we'll call that point two. Okay, let's plug in. So we're going to take our second y, that'll be 31. And from it, subtract our first y, that'll be 10. And then we'll take our second x, and I kind of put my pen through it, but don't forget that that is a negative, -3. And from that, we'll subtract our first x, -4. So if I take 31 and from that I subtract 10, I'll have 21 left. And then on the bottom, if I'm already in debt $3 and then my account goes down by another $4, I'm going to be at -7. Now, if it can divide, we should divide. Does 21 divide nicely by 7?
Yes.
Absolutely does. 21 divided by -7 is -3. No reason to reduce this. Okay, so what would be the slope of the resultant graph? -3. I don't have to put it on the graph to see that. I can just bust out my formula. Everybody cool with that?
Mm-hmm.
Now, if I had put them on the graph and I counted, would I get the same answer? You absolutely would, okay? So don't stress like there's a wrong way to go. There's not a wrong way to go. It's just today we're practicing the formula way. Okay, so the last one I want to show you is really typical of the GED. It's not quite as complex as what you'll see on the GED because I haven't taught you to find slope in all the situations yet. But this is what they like to do here. They like to give you multiple functions in different forms and then have you compare something about them. So let's take a look. It says example 8, consider the slopes of the 4 functions below. And they do give us these 4 functions here. Order them from smallest slope to largest slope. So ladies, before you can order them by slope, you better know what the slope is, okay? So let's look here. So A, my first function, I need to find slope, but this time I've been given a graph. And so when you're given a graph, you guys can watch the last video if you need a review of it. But again, you're gonna start at a point and you're gonna look at how much you change. So if I start from here, I'm at the 0 line and I go up to, and I'm going to this point right here. That's my goal right now, but I'm going to go up first. That is a rise of 2. Now, some of you guys say, Kate, that's not a rise of 2. I'm counting boxes. I'm looking at my number line. I just went from 0 to 2. That's a change or a rise of 2. Does that make sense?
Mm-hmm.
Okay. Now, I'm going to look at how much I'd have to run to get from this point to this point. So I'm starting here. Now, students will tell me, Kate, I can't tell what that number is. And these numbers are really, really small. I should have made them bigger. But this run right here is a -2. This one right here is a -4. And I'm directly in between them. So I must be at -3. Okay. Mm-hmm. And I'm going all the way back to there. So I went back 1, 2, 3. So I have a run of 3. Is everybody cool with that? So rise of 2, run of 3, that means this one's got a slope of 2/3. And of course, it must be positive because the sucker's going up. Okay, once again, and again, you can do slope on a line from any corner place, as long as you're on a corner so you're not guessing. So I'll do one right here. and right here. And again, it doesn't matter where I go. So we said when we found slope off of a line, we would go from left to right. So notice that I'm not actually rising on this graph. I'm actually
Going
falling.
down.
And I can see here that each one of these boxes is worth 1 this time. 1, 2, 3, 4, 5. So I just fell by 1, 2, 3, 4. I had a fall of 4. That's a -4 for my rise. Does that make sense?
Mm-hmm.
And now I'll count my run. 1, 2, 3, 4 again. And so I have a slope of -4 over 4. Rise over run. Now that fraction does divide perfectly, so I should divide it. -4 divided by 4 is -1. So this guy's slope is -1. Is everybody cool with that? If you're not cool with that, if I went too fast, it's because I took a 45-minute video to explain that, so y'all can go back and watch it, okay? But here's the two that apply to us today. So now look at function C. That's function C. Sorry if my labeling's off. I want to compare its slope. This time I haven't been given a graph. This time I've been given what? What is this?
A table.
It's a table. And a table has a bunch of points. And so I've been asked to find slope, and what I have is points. Now is when I need my formula. Does that make sense?
Mm-hmm.
And so we can see in the same problem, I might be using 2 different methods to find slope. That's just like the GED. They love to do that kind of crap. And after we finish all our ways of doing slope, I will give you guys a worksheet that I've made where slope is all mixed up like this. You should definitely do it because it's real easy to do this kind of slope and this kind of slope when you're doing 20 of the same kind of problem. It's much harder when you have to like jump from one type to the other. Does that make sense? Okay, so I'll call this one 0.1 because I don't like negatives. And I'll call this one 0.2. Okay, so my second y is 8 minus my first y is 0. And my second x is 9 minus my first y is 5, or my first x is 5. And then 8 minus 0 is 8. And 9 minus 5 is 4. Does this divide perfectly? 8. Does 8 divide by 4?
Yes.
Then divide it. No reason to bust out a calculator or deal with fractions if it divides. Okay, so this guy's got a slope of 2. And now our last one, and I don't like how this kind of moved over a little bit at the end here, but it's still a set of points. 1, 2, 3, and 4 points. And so because I've been given points and asked to find slope, I will use my formula. Anybody care which points I call 0.1 and 0.2?
No.
No. They're like, please just get on with this, Kate. Dear goodness. Don't make us participate. Okay, so I'll call that 0.1 and that, actually I'll call that one 0.1 and that one 0.2. Okay, so that means I'm going to go -1 minus 1. My first, or my second y minus my first y, and then I'll go 7 minus 1, my second x minus my first x. So if I'm already in debt $1 and then I go spend another $1, I'm in trouble. I'm in debt $2. And if I have $7 and I take away $1, well, of course I have $6 left. Okay, does 2 divide perfectly by 6? Then I take 2 and divide it nicely into 6 groups. No, so bust out your TI-30XS. Start with your 2. Press your N over D button. We're making sure that it's reduced. And type 6 to fraction bar 6, and I find out that reduces to 1/3. Of course, it was a negative, so it'll still be -1/3. It's really important to use your TI-30XS, especially if you're not familiar with simplifying fractions, because your calculator will deal with all of it. It's not only reducing that fractions has to happen to fractions before they get simplified. There's also a rule about there being negatives in the bottom of a fraction. It's not allowed. And so if you don't know how to deal with that, your calculator does. So anyway, FYI. That is my last example, ladies. Do you have any questions about this?
No.
No? Good? Okay, So I'm going to post this in our class. When I do, as usual, I'll put different level worksheets for you guys to try with it. Ladies, thank you for joining me. I sure do appreciate it. It was nice not having to talk to myself. And hopefully I'll see you next class when we look at slope as a rate of change and we look at all the word problems. The GED loves to hide slope in word problems.